Welcome to cryptography class. Today I am going to give an explanation for RC4 algorithm. RC4, it is implemented by Ron Rivers author, and it is one of the symmetric key encryption algorithm. So this RC4 is mainly used for generating variable key, and those keys are used as a byte oriented stream cipher technique. And the minimum key size which is retrieved from this RC4 algorithm is 64-bit, and the maximum number of key size for this RC4 algorithm retrieval is 128-bit. So this RC4 algorithm is implemented at SSL or TLS. That means at the transport layer we may able to implement this RC4 algorithm, and it is implemented for secure purpose at web browser or server side. We may also implement this algorithm under a wireless environment. It is a simple and quite easy to implement of this algorithm. If you want to implement RC4 algorithm, we should take the key size from 1 byte to 256 bytes. So we already know that 1 byte equal to 8 bits. So minimum 8 bit is required, and maximum we may implement 2048 bits for selecting key. So for 256 bytes, we are in need to initialize a state vector. So here S is a vector which contains a value from 0 to 255. So we may able to store an integer value from 0 to 255 at the consecutive locations of S of 0 to S of 255. So it is an initialization process. And we should use or implement permutation operations for generating subkeys from the set of state vector. For that purpose, another vector is or temporary vector is used for subkey generation. So this is the diagrammatic representation of performance of RC4 algorithm. We are in need of converting plain text into ciphertext format with the help of key, and this key stream will be generated from a secret key by the way of RC4 algorithm. And this RC4 algorithm contains two parts. The first part is a key scheduling algorithm. In this part, the initialization of state vector array is used or created. The second part is the pseudo random generation algorithm, in which only in the second part only the subkeys are generated, and that value is XORed with the plaintext value for retrieving the ciphertext. So if you go for a diagram, with the help of this RC4, plaintext is converted into encrypted format. So this key stream generation and the conversion of plaintext to ciphertext are done at pseudo random generator algorithm. So the combination of both key scheduling algorithm and pseudo random generator algorithm is the RC4 implementation. So the first part is key scheduling algorithm, in which the state vector name is S. We are initializing the value, constant value from 0 to 255. So this is write it in a C code, and we use a temporary value. So this is the temporary vector which is used for permutation purpose. So this temporary value is initialized with the bits which is available in a secret key. So here capital K is the secret key, which contains a minimum 8 bits to maximum 2048 bits. So we don't know the key length. So we only take the minimum value for initialization of T of I. So if only 8 bits are available, these 8 bits values are repeatedly stored at temporary value. So the first 0 to 8, 7 values are stored at T of 0 to 7. Then once again, K of 0 to 7 values are stored at T of 8 to 15. So like that repeatedly we should store these k bit value to temporary variable. And then the second step is the permutation. That means we should shuffle the state vector values for subkey generation. So for that purpose, j variable is used. So the j value is calculated with j value plus s of I value and the sum of temporary variable value. So if you sum up of these numbers, the number may be maximum of 256. So we should do mod operation. So the j value should be from 0 to 255. So we only swap that particular values of s of I and s of j. So this interchanging of bits is called as permutation. So the first part is initialization part. The second part is the permutation part. So these two parts are done at key scheduling algorithm technique. And the second part of RC4 algorithm is pseudo random generator algorithm. So we are in need of generating a key k. So k is the k stream. So initially I and j values are 0. I is equal to I plus 1 mod 256 and we should interchange s of I and s of j value. So j is now calculated as j is equal to j plus s of I mod 256. After swapping s of I and s of j value, we sum up those values. If the value is maximum 256, then we should do mod operation. This is the key stream. And at that particular key stream location, either the number is from 0 to 256. So that number is XORed with the plain text. So last line is the encrypted operation. Its previous line is the key stream generation. So this is the encryption. So if you want to do the decryption, the first 6 lines are same except MI, we should use CI here. Except CI, we should use MI here. So this is the decryption notation. So the concept of RC4 coding is drawn in a diagrammatic way. So S is a state vector which is from 0 to 255 and the numbers are stored from 0 to 255 here. Then I is the value, j is calculated as j is equal to j plus s of I plus t of I mod 256. Then we interchange s of I and s of j. Then you should sum up s of I and s of j. We should do mod operation with 256, that is the k value. At that s of k value, what is the value is available? That value is XOR with mi. So in a diagrammatic way, the same operation is drawn here. So it is the detailed RC4 algorithm notation. The first, it is a 3-part. First part is the initialization part, initialization of state vector and temporary vector. Second part is the permutation part. Third part is the key generation part. So at first part, if the length is 8, the same 8-bit value is repeatedly available from t of 0 to 255. So in a diagram, it is represented here. And in a permutation, j is equal to j plus s of I plus t of I. So we are only swapping s of I and s of j. Then after swapping, we sum up that value, that is t. So s of tth location value will be taken as key stream. That key stream is used for every bit of plaintext for retrieving ciphertext. So this is the overall operation of RC4 algorithm. So up to this video, Unit 2 is completed. I hope that you understand these concepts based upon these videos. Thank you.